To all my dear students, how are you? Today I am giving very interesting lecture about oxide and its type because it is very necessary for knowledge as well as examination view of points. So what do you see? Today is oxide and its type. So at first we have to know what is oxide. Yes. So oxide. So it is binary compound. Binary means two different elements containing oxygen and other element. Yes. So for example, carbon monoxide, sulfur dioxide, phosphorus pentoxide, nitrogen trioxide, sodium oxide, etc. So these all are the example of oxide. Why? In all cases, what we see, oxygen is a common atom. Yes. Now talking about the what we say type of oxide. Yes. So type of oxide. Yes. First one is so what is the first one is acidic oxide. Acidic oxide. So always keep in mind. So oxide of non-metal, oxide of non-metal are generally, because always they have what is the exception, non-metal are generally known as acidic oxides. Yes, they generally dissolve in water, to give acid. They generally, because they have exception, so they generally react with base to give salt and water. You know from school 6, 7, 8 class, you know. So when you talk about the oxide of acidic oxides, so oxide of non-metal are generally known as acidic oxide. They generally dissolve in water to give acid. They generally react with base to give salt and water. So for example is like this. For CO2, carbon dioxide when dissolved in water, what to get carbonic acid, that is carbonic acid. Likewise, when we talk about sulfur dioxide, when dissolved in water, what we get? Sulfurous acid. Likewise, when you talk about SO3, when dissolved in water, what we get? Sulfuric acid. In this case, 3 oxygen, us. In this 4 oxygen, so that is sulfuric acid. Likewise, when you talk about what we say, nitrogen trioxide, when dissolved in water, what we get? Nitrous acid. Likewise, nitrogen pentoxide, dissolved in water, what we get? Nitric acid, HNO3, that is HNO3. Likewise, when you talk about P2O3, phosphorus trioxide, when dissolved in water, what we get? H3PO3, and the name of this compound is phosphorus acid. Likewise, when you talk about phosphorus pentoxide, so what we have? H3PO4, that is phosphoric acid. Likewise, iodine pentoxide, when dissolved in water, what to get? Iodic acid. So you have clear? So when oxide of non-metal dissolved in water, so what to get? What you see? Acid. I have also told you that when acidic oxide react with base to give salt and water. So what we have? Suppose CO2, carbon dioxide, sodium hydroxide, that is acidic oxide, that is base. So what we have? Sodium carbonate plus what we see? Water, that is the salt. Likewise, when you talk about SO2 plus potassium hydroxide, that is acid, that is the base. So what to get? K2SO3 plus H2, that is potassium sulfide. So we have clear. So when you talk about the acidic oxides, so they are oxide of non-metal are known as acidic oxide. They generally dissolve in water to give acid and and they react with base to give salt and water. Yes. So I think you have clear. Now next one is what is the second one is basic oxide. Generally, oxide of non-metal are known as acidic. Likewise, when you talk about the oxide of metal, are known as basic oxides. Those oxides which dissolve in water to give hydroxide ions are known as alkali except cupric oxide, lead oxide, etc. So, sometimes ask you question in what you see SLC stage, school living. So, how can you show all bases are all alkali are bases, but all bases are not alkali. So, when you talk about the cupric and lead oxide, they do not dissolve in water. So, they do not produce alkali. Yes. So, likewise example is potassium oxide, sodium oxide, calcium oxide, magnesium oxide, K2NO2, CO. These all are the example of what to say basic oxide. And also keep in mind they dissolve in water to give salt and water. So, we have already studied in SLC stage. Yes, look at over here. So, K2O potassium oxide when dissolved in water, what to get potassium hydroxide plus what to say H2O, that is base. Yes. Likewise, when you talk about calcium oxide dissolved in water, what to get calcium hydroxide, but lead oxide and cupric oxide do not produce OH ions. Yes. And also they react with base, what's the acid. Likewise, when you talk about the sodium oxide, when react with sodium oxide plus dilute HCl, what you get NaCl plus what you say salt and water, that is the base, that is the acid. Likewise, when you talk about the cupric oxide base, when react with dilute sulfuric acid, what you get copper sulfate plus what you see water. So, that is base, that is the acid, that is copper sulfate. Yes, that is about the basic oxides. So, you have clear. Next one is third one is very important, amphoteric oxides. So, those oxides, the oxides which behave as acid as well as base are known as amphoteric oxides. Yes. So, for example, zinc oxide. What say? Aluminum oxide, tin oxide, SnO2, stannic oxide. In this case, valency of +2, in this case +4. Likewise, PbO and what you see, that is plumbous oxide, in this case +2, in this case +4, that is plumbic oxide. Yes, these all are the example of what you see, amphoteric oxide. But generally ask what you see, zinc oxide and aluminum oxide. So I am giving two example over here. Zinc oxide. So when that reacts with, suppose, dilute HCl, what you get? Zinc chloride plus H2. In this case, zinc oxide acts as a base, that is acid. Likewise, zinc oxide, that is zinc oxide, react with sodium hydroxide solution. Yes, solution. So what we have? Sodium zincate plus what you see? Water, that is sodium zincate. So what you see? In this case, acts as acid because NaOH is the base, you know. Likewise, when you talk about what you see, aluminum oxide, that react with dilute HCl, what you get? Aluminum chloride plus water. In this case, acts as a base, like aluminum oxide, what you see, react with what you see, sodium hydroxide solution, what you get? NaAlO2 plus H2O. Yes, that is aluminum oxide, that is sodium meta aluminum. So you know how to balance this chemical. So we have to balance all these chemical equation by heat and trial method, because I have already taught you about how to balance the chemical equation by heat and trial method, partial method. So in this case, we have to balance all these, what is by heat and trial method. Yes, so that two examples are very important. Yes, zinc oxide as well as aluminum oxide. So I think you have clear what are the amphoteric oxides. Yes. Fourth one, neutral oxide. So actually that is also very important. Neutral means neither acidic nor. So what you see? Those oxides which are neither acidic nor basic are known as neutral oxides. For example, very limited example, what you see, carbon monoxide, nitric oxide, that is nitrous, that is also known as laughing gas, nitrous oxide, water. But what we have to say over here? Distilled water. So, distilled water is what you see? Neutral. Yes. So, these are the example of what you see, neutral oxides. Yes. Next, fourth one, 5.1, true peroxide. True peroxides. So, those oxides, better to say, those oxides which react with acid to give hydrogen peroxide are known as true peroxides. Better to say true peroxide, known as true peroxides. Always keep in mind, in this case, the oxidation number of oxygen atom is -1, generally -2, but peroxide case what we have? -1. So, for example, what you see, potassium, that is potassium peroxide, when dissolved in what you see, dilute HCl. So, what to get? KCl plus what you see, hydrogen peroxide. Likewise, when you talk about sodium peroxide, that is sodium peroxide, when react with dilute HCl. So, what to get? NaCl plus what to get? Hydrogen peroxide. Likewise, when you talk about barium peroxide, that is barium peroxide, when dissolved in dilute HCl, so what we have? Barium chloride plus hydrogen peroxide. So, these all are the example of potassium peroxide, sodium peroxide and barium peroxide. These all are the example of what you see, true peroxide. Why? Because in all cases what you see, we get hydrogen peroxide. You have clear what are the true peroxides. So next one is what you see 4, 5, 6. That is also important. Mix oxides, as the name suggests. So those oxides which are composed of two or more simple oxides are known as what you see mixed oxides. Yes, for example, when you talk about what you say Fe3,4, the name of this compound is ferric oxide. It is composed of simple oxide, ferrous oxide and ferric oxide. Yes. Likewise, when you talk about second example, the first example, what to say Pb3O4. How many Pb3? Triplumbic. How many oxygen? 4. Tetra oxide. That is mixed oxide that is composed of two molecules of lead oxide, and that is plumbous oxide, that is plumbic oxide. That is plumbous, that is plumbic oxides. We have clear. So generally these two are very important for you. First, ferric oxide as well as what to see next one is, so generally 6 are very important. Now 7 one is super, as the name suggests. So those oxides which have those oxides which have superoxide, that O2 having one negative charge, superoxide are known as superoxide. In this case, oxidation number of oxygen is minus half. What we have? Minus half. Yes, minus half. For example, so generally more electropositive element only form the superoxide, not the less electropositive elements, like one rubidium superoxide, that is rubidium, what to say superoxide. Yes. Next one is cesium. Cesium superoxide. You know, cesium is the world's most electropositive element, and second one is rubidium. So what you see in this case, the oxidation number of oxygen is -half. Always keep in mind. Yes. And last one is what you say, suboxide. As the name suggests, sub means those oxides in which the ratio of oxygen atom are lower. Yes. So for example, very limited example. For example, C3O2 carbon suboxide. So structure is like this. That is known as carbon suboxide. In this case, carbon is 3, but oxygen is 2. First example. Next one is nitrous oxide. First example. Second one is nitrous oxide. What the formula? N2. So 2 nitrogen but 1 oxygen over here. So that is also the example of neutral oxide. So it is generally found in both what you see neutral as well as what you see suboxides. So generally questions are asked generally in this case is like this. So what type of questions? Generally questions are asked like this. Always ask, define amphoteric and neutral oxides with suitable example. Suitable examples. You know how to define and what are the examples. Next question generally asked, classify the following oxides with reason. We have to give reason also. Why they are acidic, why they are basic, why they are neutral, like this. So example are like this: zinc oxide, NO, sulfur trioxide, what do you say, barium peroxide, ferroferric oxide, what do you say, sodium oxide, N2O5, etc. Suppose these are the oxides. Now we have to classify this. So zinc oxide, what is the amphoteric? So in this case we have to give both reaction with base, what is as well as acid. NO, neutral oxide, SO3 acidic oxide, we have to give the reason. NO, not necessary to write any question. SO3 acidic, so we have to give the reaction with base. Barium peroxide, we have to see why they are peroxide or what you see true peroxide. Ferroferric oxide, sodium oxide, N2O5, etc. Yes. So thank you for watching this important what to say lecture, or we can say video, and also yes, I think you have also subscribed it and also convey your friends for learning. Yes, so have a nice day, be happy, be healthy, be bona fide in what's chemistry. Yes.